Hello, welcome to Feliz Math Tutor. Today I'm going to talk about radicals, how to simplify them, how to make multiplication, subtraction, addition, and division, and what is the properties of radicals. So let's start with what is radical means and how radicals look like. So I have this radical here. So this n here is index, and this sign is radical sign. And how I read this, and root of a. We say and root of a. Okay. So radicals, opposite operation of exponentials. So for example, we know 5 square is, let's say we have 5 square, we know it's equal 25. So how we can make opposite operation on 25? So when we say square root of 25, so we will come up with, so we can write it like 25 to the 1/2. Same thing with square root of 25. So we will come up with result 5. So how we can read this? This is square root of 25 is 5. How about if we have a cube root? So let's say we have cube root. Let's say this time we have 75. So we can write 75 1/3 on it. So result will be same 5. But this time we use cube root of 75 is 5. So it goes like that. So in general, we have a inside radical sign, and we have n here, which is root. Sometimes we have k here, which is power. So let me write this. This is power, and this is root. Okay, so we can write it like a to the k over n, and sometimes we want to write it like that, a to the 1/n to k. So how we are going to read it? N root of a to the k. Okay, let's see an example. So we have 75, cube root 75 to the 2. So how can I write this? I can write 75 2/3 on the top as an exponential. So sometimes I might write it 1/3 here and 2 outside. And what is a cube root of 75? We know it's 5 from here, right? We solved it before. And then, so inside of the parentheses is 5. And we have 2 here. So we will end up with 25. Okay. So let's talk about signs and roots. If we have n root of a like that, so it can be, this n can be even or odd, like even numbers like 2, 4, 6, etc., and odd numbers 3, 5, etc. So what happens if we have some even numbers? So we know, for example, we have, let's say we have 25. So 25 has 2 real square root. So we know 5 square is equal 25, but also negative 5 square is equal 25. But when we see square root of 25, we will say 5. Okay, let's say we have cube root, but in cube root we have only one result, because 5 cube is equal 75, but negative 5 is equal negative 75. So if we see cube root of 75, we will have 5, and there's no negative 75 in cube root. It's not real number. It's not real. It's not real number. Okay. So we have one more term, perfect square. So what is perfect square? 4, 9, 16, 25, 36, 49, 64, 81, and 100. These are perfect squares because, like, let's say this one, this is 2 square, this is 3 square, this is 4 square, and etc. So if it's not perfect square, let's say 75 is not perfect square. So how can I simplify it? So inside the square root of the 75, I will look for the perfect square. So what kind of perfect square I am seeing inside? Like, I can say 25 multiplied by 3 gives me 75, right? So this we know perfect square. So when we are simplifying some number which is not perfect square, so we should find some perfect square on it. So we can write square root of 25 and square root of 3. So I can write this one 5 square root of 3. So this square root of 3 cannot simplify anymore. So we will end up with 5 square root of 3. So can't simplify. Okay, so this is end of the simplification. So how about if we have some variables inside square root of or cube root of a number? So for example, we have square root of 25 x squared. So x is variable, so I can write it 5 square x squared. So both of them can go outside. So I will end up with 5x. Okay, next example, we have cube root. So I can write 3 cube and x cube. So I will find 3x. Another example, now we have fourth root. So 4, I can write 2 to the 4 and x squared to the 4, but I cannot do anything to the y. So I will end up with 2 x squared, but y inside. So don't forget 4 here and y squared. Okay. So let's see how we multiply radicals. So if we have same index, let's say we have same index n, and inside of the radical sign we have a and b, so we can multiply them because we have same index. So in our example, actually these examples are square root, but we don't have to write square root. We can just only use radical sign. So since they have same index, we can write 2 multiply 3, which is equal 6. And second example, similar, but they have in variable inside. So 2x, 3x, which is equal 6x square. Since x is square, we can take it out and write x square root of 6. Let's say we have same square root of 2x. So when we multiply them, we will get 4x square. Since both of them is perfect square, I can write it 2x outside. Okay. So let's say we have different index. So this time we have m and n. So I can write it like one of them's index on the top of the other one. So other index as an exponential of the other one. Let me use a different color so we can understand better, maybe. Like that. Okay. Just switching roots as an exponential. So let me solve this example. So in this example, I have square root and cube root. So I can write them as 2 and 3 outside as a root, 2 cube, and 3 square. So I will end up with 6 root, and this is 8 and 9. So I will have 6 root of 72. Okay. So how we divide radicals? So for dividing, like multiplication, we are looking for same index. So in here, a and b has same index, so I can divide them. Let's see in example. So we have same index, which is 2. So I can divide them. So I will divide numbers together and variables together. Okay, when we divide 72 to 2, I will get 36. And when I simplify x's, I will end up with x squared. So these two are perfect squares, so I will end up with 6x. Okay. So how about addition and subtraction? So same index and same radicand. Radicand means inside. So I'm looking for same index and radicand, which is this whole part is equal. So I can add them. So I will have 5 square root of 3. Okay. If we have variable inside the square root, like that example, so I will end up with 8 square root of x. So these examples for cube root, so they have same cube root. So root, we said root and radicand should be same. So these 3 cube root of 3 are equal, so I can add them. So I will end up with 5 cube root of 3. So I'm just only putting same cube root. I'm just adding these parts, 2 and 3. Okay, same thing with variables. So this part I'm not touching. I'm just making operation these numbers. 15 cube root x. Okay, this part we didn't touch. Okay, so we have some more properties about radicals. So let's say inside of radical sign I have one more radical sign, so I can multiply them, this m and n. For example, if I have cube root and inside square root, so I can write it like 6 root of 3. And also if I have this n and n same, so I can cancel these and I will end up m root of a. For example, if I have 8 and 6 root of 8, so I can write 6 as a multiplication of 2 and 3, and inside of the radical sign I have 2 to the 3, so these 3's will cancel, so I will end up with square root of 2. Okay, so I have one more properties, which is actually we talk about it at the beginning. So this m here inside the radical sign, I can write it outside of the parentheses, and I also can write them as a exponential exponential fraction as a to the m over n. Okay, for example, I have square root of 9, so I can write it to square root of 3 square, and so I can write square root of 3 square outside of the parentheses. So this 2 and 2 can cancel, so I will end up with 3. Okay, hopefully it's clear. So let's make some examples. Okay, this 2 we say conjugate. Let me write it down. Conjugate. So there's only a sign difference. So we have properties about that. Remember, let me write note. Remember, a minus b, a plus b equals a square minus b square. So with these properties, we will solve this example. Okay, let's say in our example, this is a, this part is b. So I can write it 2 square minus 2 square root of 3 square, right? So let's say I'm continue here. Okay, so 4 minus 4, when I square it, square root of 3, when I square it, this 2 and square root will cancel each other. So I will end up with 4 minus 4 multiplied 3, which is equal 4 minus 12. So it's equal negative 8. Okay, so I have one more example here. So let's say we have something like that, 2 over 2 minus square root of 3. So we don't like to see this negative sign expression on the denominator. So we will simplify this. So how can I simplify this expression? So I will multiply both numerator and denominator with the conjugate of denominator. So what is the conjugate? 2 plus square root of 3. Same thing here. So when I multiply this conjugate, these two, I will have 2 plus square root of 3 on the bottom, like example before. So I will square 2 square minus square root of 3 square. So on the top, so I will have 4 plus 2 square root of 3 over 4 minus 3, which is this equal 1. So I will have 4 plus 2 square root of 3. Yes, that's it for today. Hopefully you like it. If you like it, please subscribe my channel and see you in the next video. Thanks.